So you're adding and subtracting radicals. All right. Before you actually do anything with what is in that section, one of the things you have to be able to understand is this. The square root of 6 plus 3 square root of 6, the square root of 6 plus 3 square root of 6, those are like terms. And I combine them. So let's talk about this idea. If I had x plus 3x, what's that equal to? 4x. So I have 1x here, I have 3 x's here. Altogether, how many x's do I have? 4. Same idea applies here. I have how many square root of 6's here? 1 here. How many do I have here? 3. Altogether, how many square root of 6's do I have? 4. Same idea applies. Okay? So the idea with radicals is this. Radicals are like terms if the indices are the same, meaning the index, and the radicands are the same. So radicals are like terms if the indices are the same, square root, cube root, fourth root, and so on. And the radicands are the same. So those were like terms here because what's my index on both of these radicals? What's the index? Do you remember what the index is? The index is 2 because you're saying square root. If it was this cube root, you would see a 3 here, right? Okay. What's the radicand? 6. All right. So could I combine these two? Can I, not this one, but the next one, can I combine the cube root of 7 plus the square root of 7? Can I simplify that? No. Although the radicands are the same, what's the issue? The indexes are not the same. One's 3, what's the other? 2. Okay, the answer is no. Okay, so you understand how to combine or when to determine if I can combine radicals. The index has to be the same and the radicands have to be the same. Okay, all right, so that's going to take us to section 15.3 now. Okay, so this is number 2 on page 1128. Square root of 5, subtract 9 square root of 5. Now, the direction is going to say perform the indicated operations. So, in this case, I want to subtract those two radicals. Can I combine them?
Yes.
Yes. So, what's the answer? No. Negative 8 square root of 5. Because that's a 1 right here, right? 1 subtract 9 is what? Negative 8. So negative 8 square root of 5. That's your answer. Number 4, you have 12 square root of 2 minus 3 square root of 2 plus 8 square root of 2 plus 10. How many terms do you see? 4. Are all of them like terms?
No.
No. How many are like terms?
3.
3. Good. The last one's just a constant. I mean, they're all constants, excuse me. They're all constants because none of them have a variable in it. But the last one, let me rephrase. The last one is a rational number, right? The others are irrational, square root of 2s. But I can combine those because the index is the same and the radicands are the same. So I have 12 of these, negative 3 of these. So far, 12 and a negative 3 is a what? Positive 9. And then I have 8 more. So how many do I have?
17.
So the answer is 17 square root of 2 plus 10. Don't say that's 27 square root of 2. The only time that would be 27 square root of 2, that was 10 square root of 2. Is that a 10 square root of 2? No, there's just a 10. I can't combine those two because this is irrational and this is what? Rational. You can never combine an irrational number and a rational number. So that's your answer. Now, if you wanted to, you can also write it as 10 plus 17 square root of 2. That's fine. You understand? Because remember, addition is commutative. The order in which you add does not matter. All right, number 14. You have 5 square root of 32 minus the square root of 72. Minus 5. Okay, I can't combine them, but let's think about this. What can I do?
You can break it down.
You can simplify. You can simplify. That was that 15.2 that we talked about, simplifying radicals. What perfect square goes into 32? 16. And always use the largest. 4 goes into 32, but that's you have to do a little bit more work if you use 4. Always use the largest. So what I would do is write like this. I'd say 5 times the square root of 16 times 2, right? Minus, now let's get 72. What perfect square goes into 72? Give me the largest. 36. That's 36 what? Times what? Times 2. And look, there's usually a pattern to this. So when you do the first, you see how 16 is a perfect square and 2 is not? So chances are, it's not always true, but chances are you're going to have to use a 2 in the next one as well. So 2 times what? 72. 36, and 36 happens to be a perfect square. Now you rewrite it, just like you did before. What's the square of 16? 4. 4 times 5 is? 20. So that's 20 what? Square root of 2 minus. What's the square root of 36?
6.
So that's 6 square root of 2. And now you can write it as 1. So what's 20 subtract 6? 14. So what's the answer?
14 square root of 2.
14 square root of 2. Okay? So you have to use some stuff that you learned in the previous section in 15.2 in terms of simplifying radicals. Okay, 16. Okay, 16. Okay, you have 2 square root of 8 minus the square root of 128 plus the square root of 48 plus the square root of 18. All right, so I have 4 terms, and I know I can simplify the square root of 8 because that's one's easy. What's the largest perfect square that goes into 8? 4. So I'm going to write this as 2 square root of 4 times 2. So that's what I would do first. I would just rewrite the 8. Now let's go to 128. Now you see how the first one, my perfect square is 4, and then I have that 2. Let's divide 128 by 2 and see if that other factor is a perfect square. What's 128 divided by 2? 128 divided by 2 is 60. Okay. 64. Is 64 a perfect square? Yes. So it becomes minus the square root of 64 times 2. All right. Now let's look at the other, square root of 48. What's 2 divided by 48?
12. No, sorry.
24. But 24 is not a perfect square, right? So that idea is not going to help us anymore. So now 48 is not that bad to think about. What perfect square goes into 48? Give me the largest. 16. 16 times what? 3. So you see, that's why 2 didn't work, because you needed a 3. And then plus, 18 is an easy one as well. What's the largest perfect square that goes into 18? 6 is not a perfect square. 9, right? 9 times 2. All right, so that's the first thing you have to do. Now let's simplify. I'm circling the part of the square root I can rewrite. I can rewrite the square root of 4. I can rewrite the square root of 64. I can rewrite the square root of 16. And I can rewrite the square root of 9. What's the square root of 4 that I have circled? 2, but that has to be multiplied by this 2, right? So what's going to be this term? 4 square root of 2. What's the square root of 64? 8. So that'd be minus 8 square root of 2. What's the square root of 16?
4.
So that's 4 square root of 3. And the other is going to be plus 3 square root of 2. So that's where I'm at. Now, how many of those can I combine? How many terms? 3 of them. The ones with the square root of 2's. So I have 4 here, minus 8 here. So that gives me altogether how many right here? Negative 4. But then I got to add how many more? 3, so that's going to give me how many square root of 2's? Negative 1. So these 3 that I have underlined, when I combine them, it's negative square root of 2. 4 and a negative 8 is negative 4. Negative 4 and a positive 3 is a what? Negative 1. And the only thing left over is 4 square root of 3. Okay? All right, let's look at this example. Okay. We have, right, this would be 38. We have 5 square root of 18 plus 2 square root of 32. Yeah. What perfect square goes in 18? 9. So do that second step. That's 5 times the square root of 9 times 2. Plus, okay, what perfect square goes in 32? Give me the largest. 16. That's 16 times what? 2. Now I'm circling the part of the radical I can simplify further. Square root of 9 is what? 3 times this 5 is? So I get 15 square root of 2 plus square root of 16 is 4. 2 times 4 is, so that's 8 square root of 2. Can I combine those? Yep. So what's the answer? Yep. That's it. All right. So that's your part A. So that's part A. So part A, all part A dealt with, if you notice, the radicands were numbers. Okay. All right, now let's review something. Do you remember when we did this? And I asked you to simplify. Do you remember how you do this? And I think that one's either due tonight or is due Thursday, that worksheet. Square root of x to the 5th. I can simplify that. Remember we said what's the largest number that 2, and we're using 2 because my index is what? 2. Goes into that's less than 5. 4. So what we did, if you recall, what we did was we rewrote x to the 5th as x to the 4th times what? Times x. Okay? Now remember this becomes x squared times the square root of x to the 4th. So we broke apart that radical into two radicals. Square root of x to the 4th times the square root of x. Remember that? Now I can simplify this part. What's the square root of x to the 4th? X squared. So I have, I'm doing step by step. So what we have now is this, x squared times x squared times the square root of x, right? Well, what's x squared times x squared? X to the 4th times the square root of x. And so that's your answer. Okay? That was one of the worksheets. I don't remember which one it is. Thursday's? That's Thursday's worksheet. And so if you had something like 3x times the square root of 9x to the 7th y. Okay. Now what I would do first is rewrite that square root into individual square roots. So that's 3x times the square root of 9 times the square root of x to the 7th times the square root of y. Okay? Square root of 9, that's easy because that 9's a perfect square. So that's I'm going to circle that one. That's going to be 3. I know that's going to be 3. Now let's talk about the square root of 7. We'll go off to the side and kind of work on that one. Square root of 7. Let's see what this is right here. What's the largest number less than, I meant to say x to the 7, excuse me. Square root of x to the 7. What's the largest number less than 7 that 2 goes into? 6. So we square root of x to the 6 times x, right?
Yeah.
And so that becomes the square root of x to the 6 times the square root of x. And what's the square root of x to the 6? X to the 3rd, and we're left with x to the 3rd, square root of x, right? So that goes here. So x to the 3rd, square root of x. So you'll agree that the square root of x to the 7 is x to the 3rd, square root of x? Can I simplify the square root of y?
No.
No. The only time you can simplify something like that is if the exponent is 2 or more. See, that exponent is what? 1. So you can't simplify that because it's less than the index. The exponent is less than the index, you can't simplify that. So now let's multiply. What's 3x times this 3? And what's 9x times x cubed?
X to the 4th?
So it's 9x to the 4th, right?
Yes.
All right, now remember this. Just got to remember something. What is the square root of x times the square root of y? So remember what we did was whenever the index is the same, you can write as one square root. So what's the square root of x times the square root of y? Square root of xy. And so that's your answer. So it's 9x to the 4th times the square root of xy. Okay? So as a quick review for Thursday, or what's due Thursday. Now let's use this in a continuation of the next section. That's still section 15.3. So that's this part of your study guide. So we did this already. We did part A. Now we're doing part B. So here's part B. So this is going to be number 18. Number 18. Okay, 18, you have x minus 6 square root of x squared plus 2 square root of x. So x minus 6 square root of x squared plus 2 square root of x. Okay, is there any of these, now first of all, how many terms do I have? 3. Can I simplify any of those terms? Yes, think about what we just did. Which one can I simplify?
6x squared.
The 6 square root of x squared. So let's think about the square root of x squared. What's the square root of x squared? It's just x. That's x. Square root of x squared is x. So this becomes x minus 6. And remember, the square root of x squared is what? X plus 2 square root of x. And I cannot simplify the square root of x. The square root of x because this exponent is 1 and 1's less than the index. So at this point, the only term I could have simplified was which term? The one in the middle, right? Now, can I combine any of them? Yes. Which ones can I combine? X minus 6x. What's x minus 6x? Yeah. So what's the answer? Not x squared. Square root of x. That's 18. $32. You have x square root of 16x minus the square root of x cubed. X times the square root of 16x minus square root of x cubed. How many terms are there? 2. Let's look at the first one. Can I simplify the first one? Yes. What part of the first one can I simplify? The square root of 16. Okay, good. What's the square root of 16?
4.
So that first term becomes what?
X square root 4x.
4x square root of x.
Sorry.
Okay, 4x square root of x. Can I simplify the second term? Yes, because the exponent is bigger than the index. I can simplify that. So let's go off to the side and figure out how to do that. So just remember we did the previous 2 problems and what we did last week. What's the largest number less than 3 that 2 goes into? 2. So that becomes the square root of x squared times x. And I can simplify the square root of x squared. What's the square root of x squared? So this becomes x square root of x. That's this. So minus x square root of x. Okay. Now, you see where you have the radical square root of x here? So a while ago we did this. Listen to this. A while ago we did this. We had 8 square root of x minus, let's say, 5 square root of x. Can I combine these? I'm sorry, yes, thank you. Yes, I can now. So how many square root of x's do I have? 3. Okay, now what if I had this? 8 square root of x minus 5x square root of x. Can I combine those? No. Here your variable, the variable part is the square root of x. Here the variable part is x square root of x. Okay? It's kind of like saying this. Can I combine 5 plus 6x? No. So let's look at it another way. How many square root of x's do I have here that I'm pointing to? 8. How many square root of x's do I have here? 5x. Can I combine 8 and 5x? No. Just like I cannot combine 5 and 6x. You understand? Okay. So this part I cannot combine. Let's go here. Can I combine these two?
Yes.
Yes. So let's think about the square root of x's. How many square root of x's do I have here?
4.
4x. How many do I have here?
1x.
X. So it's 4x subtract x.
3x.
3x. So how many square root of x's do I end up with? 3x. So what's the answer? Okay. All right. Good. All right, let's look at number 46. 46. All right, 46. Okay, we're almost out of time, huh? All right, 46 is this. Square root of 100x squared plus 3 square root of x minus the square root of 36x squared. Okay. That one's easy. What's the square root of 100x squared? 10x. Can I simplify 3 square root of x? No. What's the square root of 36x squared? 6x. So how many terms do you see that second step? How many terms are there? 3. Which ones can I combine? 10x and a 6x. So what's 10x subtract 6x? Plus 3 square root of x. Okay? All right. Now, so part B is this. So look at part B real quick. So 1, 2, 3. So these are all stuff we've done. Now, remember the work. I didn't ask you to show any work here, so you kind of do the work on a sheet of paper. So remember though, when you get to that, like this one here, you go off to the side. Remember how I say go off to the side and figure out what the square root of 27x to the 4th is? Mm-hmm. And then you think about square root of 27. What perfect square goes into 27? 9. So you say, well, that's the square root of 9 times 3. And x to the 4th is already a nice one. So what's square root of 9? What's the square root of x to the 4th? So it'll be 3x squared times the square root of 3. So that's how you would do those. Okay? All right. So that's that one. All right. And then so we're basically done with that part of the study guide, this part here. So next class period, though, is where we're going to look at 15.4, part A, B, and the rest is old material. Okay? All right, the rest is old material. Now, so I need for you to read this. Oh, remember, I got to give you the. So there's 2 worksheets that I'm giving you. No, 3. 3 worksheets I'm giving you. The 16.3 part B, that's one with the irrational roots. 15.3 part A, and then 15.3 part B. Okay, so those are the 3 I got to give you.